Good morning, and I feel very honored to be the keynote speaker of the Women for Data Science Conference 2024. My name is Teresa Escrig. I hold a PhD on AI, and I'm currently the CEO and founder of What Matters Academy. It's an online education company, startup, and I'm going to talk today about how to thrive in the world of AI. And I have a question to start with. So how will large language models impact my job? Who is thinking about that right now? Raise your hands. Well, that certainly impacted mine a year ago. I was working at Microsoft, and I was laid off just when Microsoft invested $10 billion in OpenAI for ChatGPT and incorporated ChatGPT in all Microsoft programs. I was certainly impacted. But I think everybody will be impacted. This is not as other AI technologies that had happened in the past. I think large language models are not a hype. They are something that is going to really impact all jobs, not only AI jobs, data scientist jobs, but everybody's jobs. And we need to learn how to thrive instead of fear them or just don't know, kind of just sleep at night thinking, oh, how it's going to impact this. Embrace it and make the most out of it. So today's speech, I thought that instead of talking about responsible AI, which is something that I'm passionate about as well, is to talk about how to do that, how to embrace what is coming, the new that is coming. And, you know, the way that I thought to do that is how many times in my 30-year career in AI, I started with the second AI winter myself, when AI was not fashionable, right? All of you have started later than me. So all these years that I've been in AI, how many times I reinvented myself? And that was the way I structured this talk, is I reinvented myself 4 times. And I'm going to talk about that reinvention not to brag of what I've done, but to inspire, so that you guys can also embrace those changes and make the most out of it. So that's what the talk is about. It's full of stories. I hope you enjoy the stories as well, because the keynote is a time for storytelling. And I also want to say a couple of things. First, that it's beautiful to see women faces in front of me when I speak. And it's the second time that happened. I gave a speech also for the woman in data science a few years ago, and it was a beautiful experience because in the world of AI and tech, most of the people that are in the audience when I talk are men, and having only women faces is very comforting. So thank you. And another thing I want to acknowledge is that when I started my career years and years ago, closer, like that? Perfect. Thank you. So when I had the keynote speaker, I dreamed of the day that I will be the keynote speaker. So today is the day. It's the first day. So first phase in my career, I was in academia for over 15 years. So that was a long period of time. So I did my bachelor's degree in computer science, and that was 5 years in Spain. I'm from Spain, that's my accent. And I did my capstone project when I was already teaching at the university. I remember I was 24, and the classroom full of people, even more than here, my voice was trembling. And because the students were as young as I was, they didn't know I was going to be the teacher, right? It was very, very nervous-wraking. But today I was too. So that doesn't go away even after 3 years and many conferences and presentations. So it's always going to stay. I did my capstone project in voice recognition. So in 92, I finished that capstone project in 92, and the project was voice recognition of the first 10 digits from 0 to 10 using Markov models, which is one of the neural networks that you guys have evolved towards something that was the origin. Then I spent 6 years doing my PhD in qualitative modeling for service robots. That was the PhD. And I got the best PhD at the time. And also the National Prize of Science and Technology with that book that is over there. I don't know if I can point here. Let me try. It's not. Here. So that book, I designed the cover of that book myself as well, and I won the prize. In 97, I attended an AI conference in Japan, and those dogs, the eyeball dogs from Sony, were exposed, and I absolutely fall in love with those dogs. So I said, I'm going to use those to teach my students everything they need to know about computer science, about algorithms, about robotics, and everything else that I can teach, because they are so cute, they are going to want to learn. So we were playing soccer. We were also, those dogs didn't have the software to walk. So we were on the ground, 4 legs, trying to mimic the way a dog will walk to then write the algorithms for the dogs to walk. And I directed like 100 capstone projects at the time. It was beautiful. I also was the head of a research group and published 130 peer-reviewed research papers in the whole time at the university. I directed 2 PhD theses. I will talk about that later because I have a slide. And we used also the other robots, the Pioneer robots and Kepra, to do research as well as teaching. Oh, the RoboCup competition was, we participated in one challenge at the end, and the challenge put together all the research that we were doing in my research group for 10 years. And I wrote a paper in a weekend. My mom was with my little baby at the time when I wrote that. And that was a patent and a company that I started after that will also come up. That was another project that we work in research. Where I lived in Castellón, Spain, 90% of the tile companies are there. And at the time, the mosaics were built by hand. So we automated the process, and using qualitative modeling instead of statistic models as you guys are using, only qualitative modeling. For any design of a mosaic, the R manipulator was picking up from the table and placing it in the right place of the design. And that was the last, this was the projects that were under the 2 PhD theses that I directed. It was also, we had 50 peer-reviewed research articles. Those 2 PhD theses also got the best PhD award at the time, and is cognitive vision system. So I'm going to explain briefly because I have some other project that I want to explain, and we have only such a short period of time. So it goes first with color segmentation of any image to get region extractions. And those regions then are compare the regions using 4 qualitative models: orientation, topology, shape, and color. And then we describe the regions using those models, and we connect an ontology to know the names of the objects that can be found on the image and what we do with that object. The ontology will have that information. We used it in robots for computer vision in robots, and this is still active and current, even though computer vision now is done using deep machine learning, as you all know. So the story of the IVOs, the challenge that we did, it was basically kidnapping an IVO from the soccer field, and then place the IVO back, and with the camera of the IVO, which is inside the robot, the robot had to know the position, looking at the corners of the soccer field, and then go to an XY determined by the person that was defining the challenge, right? That challenge put together all the pieces that we were working together and was the origin of my first startup, Cognitive Robots. And we applied that to Scrabble machines, commercial Scrabble machines, and other robots. We even developed our own companion robot, which is there to the top right. And we applied a small portion of it to forklifts and school buses to create safety. This was my second startup, and I was already in the States when this happened. It was a small consulting company, and the project that we did was for a startup here in Seattle that were developing a chip for DNA sequencing. The technology was nanopore technology in each one of the chips. So you have here a picture. It's a square centimeter chip that contains 30,000 nanopores like that here. And the result of throwing inside the DNA strain is a time series signal, like the one showing here. And they were still doing research with the chip, so they applied machine learning twice to classify the basis of the DNA, and failed because it was unstable. So they look for qualitative modeling, which is another way to solve problems, right? That I'm an expert. A small piece of the computer vision algorithm that I developed with the robots was useful for DNA sequencing. So we represented using angles, up and down, and relative length of each one of the segments of the time series signal to represent the peaks. Each peak corresponded to a DNA base. And then we compare the peaks to classify them. They went from 30% accuracy in identifying the base of the base of the DNA to 84% accuracy, still with unstable data, so they could continue funding the company. That's what they needed. I presented a patent, was award, not for the DNA, but in general for time series signal with transparent analysis using qualitative modeling. And then I sold it to Accenture when I joined Accenture. Is there? Oh. Why is not working? I ran out of battery. That's you, right? It will be easier to see it if I continue explaining it, because there are details like the ones I just explained. It's better to see it. So let's hold a moment. What happened? You went to the other side? Wow. By the way, you could also download the presentation in your phone if you wanted with that QR. Oh, there. So after that, let me see if I can. Whoop, there. I was offered a position at Accenture, the AI global lead of cognitive computing and computer vision, very long title. And I did several things in that company, but the one I am most proud of is the providing transparency to autonomous vehicles. I led the development of that project. And basically, autonomous vehicles contain mostly, as you know, deep machine learning, which is quite opaque. When there is an accident, the whole industry stops. They have to check the algorithms, but there is no line of code to go. So the only thing they can do is to repeat the accident with another autonomous car in the same spot. It's quite a big problem for the industry. And we also know that they said that for 2020, we will have all the cars being autonomous, and the maturity of the algorithms is very difficult to assess because it's machine learning algorithms, and you guys know what that means because you are in the field. So what we did was to take the Apollo open source software and interchange one of the modules to provide transparency in how the decisions of the autonomous car were conducted. So basically, we provided that decision. That's why it was transparent. So here's the UI. And you can imagine that the blue circle is the autonomous vehicle. And the rest of the circles are other cars that are running around the autonomous vehicles in a highway. So when there is a danger, the color changes to red. And this is the example here, is red because this car behind the autonomous vehicle is getting too close. So the decisions that are available to the autonomous car in this situation, in that context, the ones in red are not. So in the middle of the highway, you cannot stop and you cannot decelerate in this case because you have a car that is too close from the back. So you can only choose accelerate or turn to the other lanes. And the autonomous car will decide which one, depending on the other situations, like 5 minutes. Wow. Okay, I have many more slides, so I will do whatever it comes. So let me go back. So you can store all the decisions in a history decision, and you have here like a video where you can go back and forth in that decision, and it's stored the context, so the why the autonomous vehicle also made that decision, because you have the context. And here I have the technology under the hood, which is very interesting, is passing the quantitative data into qualitative models, using 3 different qualitative models, adding traffic rules with reactive and deliberative rules for safety and accelerating the process. And then you have the UI that I just showed you before. So I need to do a mental map on how I'm going to conduct the last 5 minutes. At that time, I wrote a book. You can access that book also in Amazon. Safe AI is for CEOs to harness the power of AI without the unintended consequences. And that probably brought me to Microsoft, that book. And I was hired to do to bring into practice the responsible AI in Microsoft Consulting Services. And the first thing we did was add in MLOps. You probably are also familiar with MLOps. Hopefully you use it constantly. We added the modules that are shown here in the orange boxes to add all the tools that Microsoft already had developed for responsible AI. And we also designed a way to explain to business owners how the machine learning algorithms were working, so they could select the ones that work better for the cohorts where they were going to deploy the algorithms. And that's the way that we represented the bias in the data, what relevant features are being used to develop the model, and what cohorts the model don't work with. So we recommended not to use the model for those cohorts. And then I moved within Microsoft to another group. Responsibly, I was too political in Microsoft, and I couldn't do much. So I moved to a group that was doing machine teaching for autonomous AI. And machine teaching is different to machine learning in the sense that you divide the problem into skills and train each one of the skills separately using the best technology that exists to solve that problem. And then combine them. It's very powerful. It's what is called also hybrid AI. And I really love that technology. We used it to solve a problem in the aerospace industry when to put fuselage of planes together. When they transport the fuselage parts, they get all messed up in transportation. And that's a huge problem engineering problem for them. It's a multi-billion-dollar problem. They have to create seams to put together the two parts of the fuselage, and it's very difficult to calculate because the fuselage is very large, right? They solved the problem using divisions that were exact, and with qualitative modeling, I came up with dividing not in an exact way, but using concavities and convexities, and then using deep reinforcement learning.